Remember that cos is which coordinate, x or y? X. So along the bottom here, I've got 0, pi over 2 pi, 3 pi over 2, 2 pi. I've got the different radians for once around the circle will get us to 2 pi. And what we're going to look at is what happens as the angle changes, then what happens to cos. And cos is our x coordinate. So on the little unit circle that I have drawn here to the left, I've got cos labeled and I've got a red line. So if we start right at angle 0, if I drag that down to angle 0, does it make sense that cos is equal to 1? You see how my little dot there is really close to 1? And as I go up to 90 degrees or up to pi over 2, you see how cos is getting smaller and smaller and smaller. And right at 90, it's equal to 0. Well, it kind of hops over there. And then here, my x-coordinate is negative, so my graph is going into the negatives until it gets to -1 here. And it comes along back to 0. And then back to 2 pi. So we're going to know what the cos graph, if you turn to page 515. On page 515, they have the cos graph drawn there. Right beside that, I want you to draw the cos graph. And for your cos graph, these are the key things that you need to know. You need to know that it goes up to 1 and down to -1. We're going to put the axes family along here, because those are key points that you know. You know from your unit circle that cos starts up here, because it's the x-coordinate, and cos of 0 is 1. Then at 90, it's at 0, down to -1, back to 0, back to 1. And we draw a nice curve through the points as you go along. And it continues in this pattern over and over and over again. And this is the graph of y equals cos theta. Now if we go back to the same thing and add sine, and take off cos, move it back to 0. Does it make sense that since sine is the y-coordinate, right at 0, it's at 0? And now you can see the blue line here. That's our y-coordinate. As we go up, that blue line increases until you get to pi over 2, where it's equal to 1. Back down to 0. Down to -1. And back to 0. Now you have the sine graph on page 514. Right beside it, so on page 514, whenever you draw the sine graph, again, we're going to mark up to 1, down to -1, put all the axes families on there. Notice how I make it. I start by labeling 2 pi, then I cut it in half for pi, and then I cut it in half again. So you make 4 equal sections. And now our sine graph starts at 0, goes to its maximum, back to 0, down to its minimum. And again, we draw a nice curve through those as well. Now we'll quickly look at the tan graph before the bell goes.
Where's the tan graph?
It's going to be on the next page. So I'll take off sine. Tan starts at 0. Now on the graph here, if you drew a tangent at that point P, from that point down to the x-axis, that length is the actual length of tangent. And as you keep going, tangent gets bigger and bigger and bigger and bigger until it's undefined at pi over 2. And so we get a tan graph that repeats itself. Isn't that crazy? On your unit circle, so you have the tan graph on page 516. For your tan graph, at pi over 2 and at 3 pi over 2, it's undefined. So we draw that by making asymptotes. Tan of 0 is 0. If you wanted to, you could put a point on here because you know tan of pi over 4 is at 1. And your tan graph kind of looks like an x cubed graph. Okay, it's not quite the same shape, but then it repeats itself over and over again with the next asymptote at 3 pi over 2. So those are the three main graphs, and then we're going to do transformations with all three of those. In particular, we're going to do them with sine and cos.